Hi everyone, my name is Soufian. Today I'm going to present to you our first version of SecurePoC, which is a helping tool that helps analysts deal with malicious proof of concepts. Before I dive into the tool, I want to give a little bit of background about why and where and how we started this research. So I'll start with a little bit of information. Most of the security analysts, and that includes pen testers, red teamers, security researchers in companies and academia, they use a lot of tools or have been using tools since the 90s to actually automate a lot of attacks like Metasploit or ExploitDB, and most recently Nuclei, which is basically open source and built by and for the community to actually exploit attacks. Now, these tools basically gather a bunch of CVEs that you can try and test if you are doing pen testing assessment or red teaming assessment where you can test vulnerabilities. However, the most emerging one is actually GitHub, where recently a lot of security researchers started posting and sharing their proof of concept or how to exploit vulnerabilities in GitHub. And of course, we know that GitHub is really used for a lot of other open source projects, but one of them is actually building and sharing proof of concept of attacks, like the most recent one for SharePoint that happened a few weeks ago. We noticed a behavior where basically those proof of concepts are for security professionals, but are actually sometimes targeting security professionals. And the problem with this proof of concept is that there are no solution that helps you identify which ones are legit proof of concept and which ones are not. No prior investigation of this proof of concept. We'll get a little bit more into details why we need some sort of analysis, which is what we did over the last almost 4 years, actually collecting proof of concept and analyzing them to see why nobody actually checked these proof of concepts. And is it just overconfidence by analysts, or is it just trust between the security community, or is just ignorance? Recently, a lot of security professionals started raising awareness around this proof of concept, where many of them shared that they found malicious proof of concept. So researchers create proof of concept to exploit vulnerabilities in the wild, but also they embed malicious content that hacks you as a security professional, which makes the damage even bigger if you are doing a pen testing or a red teaming assessment within an organization. If they hack you as a security professional, they can compromise the organizations you are working for as well. The most recent one was just released like 2 months ago by Reversing Labs, where they found around 60 proof of concept that is actually malicious, and it's sharing a lot of malicious content on GitHub. And they shared a detailed analysis on how they found it and what they found in that data, so feel free to check the article if you are interested. The most alarming thing is that a lot of security companies, security professionals are promoting proof of concept, but they're actually promoting malicious proof of concept. And these are just examples that we found where those professionals shared, this is the link to a proof of concept, but it's actually malicious one, because basically they didn't check the code. And that's what actually motivated our research and actually why we wanted to build the tool, or at least the first version of the tool, why we wanted to build that tool to actually help analysts analyze the code, or at least pinpoint where and how to actually investigate this proof of concept. Which leads to our tool, SecurePoC. And SecurePoC is basically a tool that, it's a modular tool, which makes it easier for security analysts to add their own modules for detections, obfuscation techniques, extractions, integrations with third parties that helps you analyze vulnerable code or sandboxing or all kind of solutions. So we started with data collection, and that's the process that have taken us last 3 years, where basically we collected data on in multiple occasions. The first time that we did that was in April 2022. So we collected data of CVEs that are created between 2017 and 2021, and basically those CVEs are targeting CVE-2017, means CVEs that have been released from in the year 2017 until 21. And then we recollected the data earlier last year and also later last year. And the total is around 20,000 proof of concept that we actually analyzed after deduplication and cleaning. And by deduplication, I mean excluding forks. And that's also another alarming problem where people are basically just forking this kind of repositories and using them while they actually are or could be malicious. If we take a look at the most used languages, of course, Python is still dominating. Most people still use Python, easy, simple, straightforward to build the PoCs or basically create your own tool around detecting some sort of vulnerability. And then we can see that there are a lot of other languages, and probably that means because it's targeting a specific kind of systems that is based on Java or some other programming language. The other thing that we did a few months ago is to actually analyze these PoCs and see how they actually are changing. Did they had any changes? Did they had any updates? Or did they had any takedowns? And we noticed that the majority is still unchanged. A few of them have been taken down by GitHub, which could be because people are reporting. We are also reporting our findings to GitHub so they can actually take down the repositories that are malicious. And some of them are basically just having some updates or changes on this data. And this statistics are actually as of March this year. If we take a look at the repositories in the CVEs per year, you can see that there are a lot of CVEs per year that have been released. But if you go to between 2019 and 2022, you see that the amount is actually bigger. And that's due to 2 or 3 very big vulnerabilities that popped up during this year. And that means Log4j, Bluekeep, that actually were emerging. So everyone was basically creating a bunch of PoCs, and everyone was jumping into the vulnerability, which makes it even easier, makes analysts easier targets because, yeah, they just want to use the tools. So the tool itself, it uses, like I said, a modular system, which is basically you can integrate your own modules. So we built some basic ones ourselves, like for extractions of hexadecimal base 64 encoding, as first obfuscation techniques that we have seen in the PoCs that we checked manually. And we also extract all kind of communications with IPs, with URLs, or binaries that are encoded. And why we talk about IPs and URLs, if there is a PoC, we assume by default there shouldn't be a TOC that is already communicating with an IP address. If you are trying to exploit Bluekeep or Log4j, you need to provide the IP. It shouldn't be hard-coded. That, of course, leads to some false positives that we also will share with you later. And then we integrated also with a bunch of other third parties that you can also extend if you want, like VirusTotal, or Abuse IPDB, or other sources that helps you actually check the detections and see if they actually help you figure out if it's malicious or have been already flagged. That also have some false positives on that side. One of the main reasons why we built the tool is to actually minimize the effort that the analysts do. So if we check the amount of lines or the bytes that the analysts have to analyze, if they check all the data that we have, it's millions of lines of code that needs to be checked. And that's a problem if you are basically dealing with just these kind of proof of concepts. It's a lot of work. It needs a lot of manual work to analyze it. So one of the first things we wanted to solve with the tool is actually pinpoint where is an encoded binary or encoded base 64 or hexadecimal or all kind of obfuscation that might be there, or also if there are binaries that can be flagged by third parties as malicious. The second thing we will show you here is basically our detection, what we found. So for example, you see what kind of heuristics here, how many have been flagged, and how many IOCs have been are being flagged in there. So there might be like one repository that have multiple IOCs, and that means multiple binaries, multiple encoding of base 64s or hexadecimals that have been decoded into a file, a zip file, a binary, and sometimes into a code that actually will be executed in the machine once it's running. The next thing we wanted to do is to actually check the true positives and the false positives analysis. So we took a sample out of our data and we started analyzing it from all the heuristics that we implemented at this stage and see how many are actually true positives and how many are false positives. So for the false positives, you can see that we have few false positives, and that's basically because It could be a short base64 detection that is being used to actually send to the server that actually you are trying to hack instead of some encoded script that is there. And the same for IP addresses or hexadecimal. For binaries and URLs, we of course relied on third parties, so like VirusTotal in this case. So we checked why VirusTotal is flagging those, and we found out that the false positives are basically just some hacking tools like Mimikatz or any kind of tools that are being used by red teamers or pen testers. So they flag them as malicious, while in our case they are not really malicious because those are hacking tools that can be used by analysts. One question I just got before the presentation, so what's the attribution? That's why I just added this slide, which is what's the attribution between the amount of PoCs and the amount of, or the CVSS score. So this is an analysis which is from the second author who also did this analysis for his master degree. And you can see that the amount of PoCs is really high when the CVSS score is really high as well. And that's basic because most of people, when they create proof of concepts to exploit attacks remotely, local file inclusion, remote code executions, and all kind of vulnerabilities that doesn't necessarily need some sort of access or known information, because it's basically easy to exploit, and you don't need any kind of information, which makes also the score goes high from a CVSS score, of course. I have few use cases that I wanted to show you, and I'm going to start with one that we can detect, but we don't know how to deal with, which is the PyArmor. I'm not sure if you are aware of that, but PyArmor is basically a library that have 3 layers of dealing with the code. So you can give the library your code. It obfuscates the code, of course. It does some byte code protection, and also it implements some anti-debugging techniques on it, which makes it almost impossible to actually know what the code is. So you can see it, you can detect it, but you don't know what it is. The only way you can know what it is to actually run the code in a sandbox and see if there are any malicious activities happening and analyze it. So far, we are not aware of any technique of actually how to deal with this code other than dynamic analysis. The second use case, which is a crypto miner that we detected. So we worked in this case with Datadog, and this was attributed to a threat actor that was labeled MUT 1244. It was also presented in DEF CON last week, where we basically can see here that this is the script. It's for vulnerability, where basically the code is actually legit. Except there is a part where they added a base64 encoded script that will also be sent and decrypted once the PoC is running on the machine. And here, once we decrypt it, you can see that they have multiple layers of obfuscation. So you can see that you take the base64, you decode it, and then you get this. And here where we started to see a bit more about the crypto miner after the second, or actually the third deobfuscation level, where you can see that they download some malicious files, and then they try to hide those files by using hidden files or directories, and then create some sort of persistent where basically it's really hard to actually detect this kind of crypto miner. This crypto miner was attributed to this threat actor, like I said, and this threat actor was actually, like Datadog was able to compromise their command and control server, and they were able to get 390,000 credentials, and most of them, they were attacking pen testers, red teamers, and academia. Unfortunately, my university was also part of it, so I promise it's not me. The third use case, it's actually a repository for KeepBlue as well. And then you can see that, of course, they have a base64 as well, and then they actually send it within the code. So it's there, but yeah, you see the code. Most of the code is actually legit. And once the code is executed, or once we take the base64 and decode it, we find that it's actually, this is the first deobfuscation, and then we deobfuscate it. It's a PowerShell deobfuscation, actually. And then once we did the PowerShell of deobfuscation, we found out that it's communicating with this URL and trying to download that binary, then executing it in your machine, We suspect, since when we check the domain, it's been existing for too long, we suspect that they actually compromised that website with some WordPress vulnerability. They hosted the malicious file there, and then they used it to actually compromise or actually deliver their malicious code. And just before I close, I would just want to show you a little bit of a demo just for a few seconds on how the tool actually works. It's pretty straightforward. You just need to run it. And then you can either give it a URL, repository, a specific repository, or give it basically a directory that contains multiple repositories. And then it starts flagging which actually systems or which kind of PoCs that actually might have malicious content that you actually need to check. And of course, it delivers some sort of extra information from third parties that you are using, VirusTotal, Abuse IPDB, or any kind of sources you use like URL scan or anything. This is just an example where basically we are extracting the data that was shown, and then we basically decode it to see the final script that was done that was included in the tool. To conclude, as far as we know, we were the first to actually detect this problem. We already published a paper about detecting the problem 3 years ago. The tool is pretty basic at this stage, but we are working with security professionals to improve it. So we are going to open source the tool and basically make everyone contribute to the tool where they can implement all kinds of detections. It's really hard to actually implement a lot of detections. You can come up with thousands of obfuscation techniques, encryptions, all kinds of techniques that you can use. So we can start with the basics and have some hints towards what kind of obfuscation techniques are used, but the amount is really unlimited. So we need to work more on how we can improve that and give the users a better solution that helps actually reduce the amount of false positives. Yeah, like I mentioned, the tool is going to be publicly accessible on GitHub, and then everyone is welcome to use it. And if everyone is interested in the data sets, so we have data sets from 2022, so please feel free to reach out. That's it. Thank you.